We're going to get going with this because I know there's lots of excitement. There's going to be a little bit of mushroom cookery, but most importantly, there's going to be a whole bunch of identification in it as well. We're so happy to have Dr. Bruns here from California again talking on this topic. As I mentioned in the quick bio, you know, a very impressive 22-page CV that I got, which I melted down to 3 lines, so it doesn't do a lot of justice. But interestingly, as I was researching my Bowley talk a little bit, going through some different things, the guy's name kept coming up here and there. There's one that's attached to him, and here's another one. So it's always interesting to actually meet these people that do so much of the work, that help us out as amateurs and teach us so much. So with that, I'd like to have Tom talk about the most exciting project that's going to happen in mycology here.
Great, thank you. I want to thank Martin for inviting me, and for more than inviting me, for bugging me until I accepted it. I'm sort of terrible with emails, and I don't know how many it took before I finally responded. But it's been a great pleasure coming up here and interacting with you folks, and getting to see your great Microflora here in Alberta. And I really had not had a chance to see that before, so it's been fun. So what I want to talk today about is the North American Mycoflora project, and in some ways it's total vaporware. It's an idea that we tried to launch last year, and there's a lot of excitement about it, but it's like trying to push a 80-ton marshmallow. You know, you're like pushing in and nothing's moving. It feels like you're moving something, but nothing is moving. So what I want to do is give you sort of the outline of what we're trying to do with this, and how you guys can help push this big marshmallow. So to start with, when you're home and on the internet, you can search for North American Mycoflora, and you will get this website. And if you get this website, you can read through the material on it, and you can look at things like the meeting we had last year and see that it was well attended. We had, I think, 70. I'm sorry, I'm in your way here, aren't I? I don't know where I can stand up. We had, I should have looked up the numbers again, but somewhere in the mid-70s of people there, and they were both professional mycologists and people with day jobs too that were serious amateur mycologists. I'll show you a couple close-ups here of some of the folks. So people like Gary Linkoff and Noah Siegel and Mike Wood from MycoNet, and Mr. Amanita himself, Rod Toulouse. And if you get interested in this meeting, you can go click on the presentations, and there's an outline of what there was, but more than that, there's videos of them. You can go listen to all the presentations, so you can sort of attend the meeting a year later and see what it was about. In fact, you could listen to my presentation, and it's going to be frighteningly similar to what you'll hear tonight. Okay, so what is this thing? Let's go through a few questions about the Mycoflora. First, what is a Mycoflora, and how is this going to be different from a field guide? We're thinking of sort of a bookish thing here. And if we go back to the website here, you can click on the glossary, go down to Mycoflora at the end, and if you bring out your hand lens, you can probably read that, or I'll blow it up for you. So Mycoflora is basically a mycological equivalent of a flora. You know, you could pick up probably the flora of Alberta, right? And in that flora would be all the plants in Alberta with good keys, correct nomenclature, distributions, and it'd be tied to specimens. There'd be lists at the back of each one as to where these things were, what herbariums and stuff. That's what we're talking about. That's what we want for the fungi, something equivalent to that. And the terminology here, there's actually a lot of names you could apply to this. There's more modern names than Microflora. I like the name Mycoflora specifically because I think it's very transparent to people that don't know mycology and so on what it means. That it means that it has this meaning of a flora-like thing focused on fungi, where we could use terms like mycota or funga that sounds like maybe you'd need a cream to alleviate it from your skin. And those are terms that mycologists use when they're talking about things like this, but I think we lose the rest of our audience. And as I'll get to at the end, we need a broader audience because we don't have enough mycologists to sort of push this thing forward. We have to have other people sign on to this and say, yes, we need this thing, or it's not going to happen. So I think we have to communicate with those people. And also it connects up with the term of floristics. When we talk about floristics in plants, we're talking about comparing floras across areas. And so an equivalent term could be mycofloristics, where we compare microfloras across regions. So here's some examples of modern mycofloras. And you'll see they're all European. We don't have a mycoflora for even a county in all of North America, as far as I know, like a reputable one. We've got some that sort of claim to be but very old, and they don't fill the bill. Or a state, or a province. No major region has a mycoflora. It's pitiful.
I'm working on it.
Are you?
For Chicago.
All right. We do have field guides. We have a lot of field guides. We've got them all back there, right? And very useful things. And they've gotten a lot better since I started doing it. I remember when I first started, the field guides were awful. You couldn't, for one thing, they were very incomplete. Like most of the fungi you would pick up would not be in them. So you'd go to key out and you'd get to some end of the key and go, well, this isn't it. And then you're stuck. So now we've got a lot of good ones now, and a lot of good colors gotten cheaper, so there's lots of good color images. They're useful, but they're not a mycoflora. So what are the differences here? The essential difference is that mycofloras are collections of monographic treatments. So learned treatments on single genera and families and so on, and they're comprehensive. And so all known species found in a range have to be included. You can't just pick your favorites or the ones that you happen to have pictures of. You've got to get them all in there. We want it comprehensive. Descriptions are going to be more extensive. They're going to include the microscopy as well. So when we're fiddling around with these things and we go, oh, is this thing a clitospe or a liofilm, and how are we going to sort it out? Well, okay, you go and look it up, and you'll probably end up with the microscope to do that. But field guides, sometimes you can't do that. You can't go and find the concept difference between these genera. Ranges and habitats are going to be in that, and I'll come back to that. I think that's really important, that more than just identifying it, you learn something about it. Where else is this? What does it do? Where do we find it? For me, I have to confess that I am not a taxonomist. Me pushing this forward is kind of ironic because I have not, I've described like 2 species in my life and never done a monograph. What I do is ecology, but taxonomy is fundamental to ecology, so I'm sort of hooked on it, right? So it's an important tool. Okay, so going back to what a monograph is, I think I already went through that, and I won't read this all to you. So, but in a modern monograph, what are we going to strive for? What do we want in this thing? We want it to be comprehensive and accurate and current information for the targeted taxa, easily edited. I think that's important because when as soon as you write these things, they're out of date. And so it should be something that's easy to fix. It's got to be specimen and sequence based with cross links, so that when you've got a species description, you have a list at the bottom of that of the specimens that you looked at on which that description is based, right? And sequence linked to it. So, okay, these sequences match with this species concept. So if somebody can enter into it from a number of ways, they can match the sequence, they can match the description, but you get back to that name that's all linked into it. You've got to have great keys with lots of illustrations. Lots of color images, not one, but many for a given thing. It's got to be portable. So we can't have like an 8,000 page thing that you've got to lug on your backpack. It's got to be a portable deal. And it's got to be inexpensive to users. That's my wish list. Let's compare it to what a monograph looked like 20 years ago. Here's the only kind of comprehensive North American monograph that I can think of a group of macrofungi. This is the North American polypores by Gilbertson and Rivarden. How many people have used this? It was a pisser, wasn't it? It's really tough to use in many ways, but it's all there, right? It's all there. And so if you look at that, you can see right away. You can blow up this description and see that it's got diagrams of what the description of what the microscopic characters look like. And down here, this little thing is saying this specimen is what this is based on.
And look, you can find it in Drayton Valley.
You've got a map. You've got a map of distribution, and that map, each one of those points is based on one or more specimens. So it's not just a rumor that you've got it in Alberta, but you've got a specimen in some herbarium that he looked at, and he looked at that and went, okay, this is that species, and it's there. Cool, huh? But, of course, since it was published, the name's changed. And it turns out that in that book, which was published, I think, in '83, a huge number of names have changed now. So to use that, you constantly have to go through it. So if we look up this name now, in a sort of a modern version of how this Microflora will probably work, a unit called Mycorrhizal that I'll come back to in a moment, we can find two records of it from North American herbarium. One is from down here, and the other is from up there. That's because so far we don't have many of the records actually digitalized, but it's just starting.
It's also because it only shows ones that have latitude and longitude.
Ah, okay.
So there's might be a lot of records that have a common
Right.
state but no latitude.
And this brings up a good point. Earlier in this discussion we've been having about this, somebody asked, why is the location data so important? It's important because if you want to get things mapped automatically, there has to be longitude and latitude associated with it. And when you've got that and it's digitalized, it's like that, and you've got a distribution map. It's beautiful.
Why didn't they use the information from the article to show?
Because a lot of those did not have longitude and latitude. They will eventually get in there, but there are things like county records and stuff, and so there's ways to kind of jazz it around and get there. And eventually, this should look like the other record. Only better, because on this one, you can click on that dot and blow it up and see exactly where that came from. And you can click on that dot and look at the record itself. And so you can see that this record, it was originally called Horia, so another earlier name. It was collected in 1897 by Earl. That was the record that was mapped out there.
So they did the longitude and latitude then?
They took this one and digitalized it. So this says verbatim coordinates. So I think what they did was they took the county township and range stuff and converted it.
So they didn't do it in 1897?
I doubt it. The GPSs then were really primitive.
Usually herbaria really pay a lot of attention to type collections. So all the type collections in New York botanical collections would have been further researched, and they would have made an effort to get laps and longs. So because they're very important to type collections.
Right. And so Mycoportal, the other thing it'll have, and does have, but not for this one, is that they'll have images. So you can pull up the image. So for example, if you put this stuff in Mycoportal, that all your records from this, and you had photos with it, you could put the photo right in there. And then the next click would be to pull that up, and this is what that critter actually looks like.
Yeah.
This is a modern collection of it that I struggle with to identify. It comes from California. If we go back to that monograph, though, the North American polypores, and you look at the keys, they had keys to the whole thing, and those keys were difficult. They were amazingly difficult to get through. But you know, nowadays, we have some great keys online, right? For example, the key console. You can go there, and the polypore key by Gins is illustrated. So you can see, you can get pictures right with it and know what's going on. And when you click on the, on number 17, it takes you right to number 17. And you can backtrack in it when you decide you went the wrong way. So it makes it easy. And I think this is the way keys are going to be. It's going to be electronic.
Why do you actually need to go through the process of like these binary questions if online now you can plug in the specific characteristics of it and then the computer does it for you?
Okay, so I just want to say to the rest of the audience that I did not plant that question, because my next slide is that I want to talk about synoptic keys. So in that original monograph, they tried a synoptic key, but these things were even worse at the time because you had to bookkeep it yourself. But with computers, synoptic keys are cool. You can really get through quickly, and the sort of key site for synoptic keys is discoverlife.org. Have any of you looked at discoverlife.org?
Discover what?
Discoverlife.org. This site. Homework. When you get back to your computers, type in discoverlife.org and look at these synoptic keys. He calls them something guides, ID guides is what he calls them. But what they are synoptic keys. And he's got them for all of life, basically, except the fungi. Here's the fungal one. There's a North American fungal key with absolutely nothing in it. And then there's these that are actually pretty good. I'll show you one of those. There's this one that Andy Miller did with Xylera AC. And so the way it works is you've got little images of the things. You just go through and checkbox it. And you go, okay, and maybe you don't know them all, maybe you know this one and not that one. You click two of them and then you have it limited down to the next set. And you'll see, okay, maybe there's only 5 things in there. You can click on each one and look at them if you want. They're amazing keys, actually. I think that, and what really drives them is that they're image rich. You don't need all the technology or all the terminology that you have to learn. And when you do have terminology, you can click on and get a definition right away with images. So it's the way to go. You know, it's the 21st century. We don't need to go through dichotomous keys anymore. But we have to write these.
Well, I bet you also have to be connected to the internet, so you can't pick this up in English.
You know, it's just a matter of time before that won't be true, because I think this will be on your cell phones, and probably downloadable as a unit on your PDA or cell phone. Yeah. Yeah, I know. we won't have reception in a place like this, but it's going to come. It's going to come, and I think what we have to be looking to is the future, not sort of what the way to do it in the past was. And honestly, if you haven't looked at these keys, go look at them. And the guy who's behind DiscoverLife.org, Pick, he gave one of the talks at the meeting. Go listen to his talk. He's very charismatic, and he's just turned on by the idea of citizen science, of people like you documenting life on the planet. And he's got a great example for moths. He's really into the insect world. That's why the insects are so filled out. But he's 100% behind this, and is right there to assist people that want to make these keys. There's a whole language to do it, and it's not hard to learn from what I've heard. I haven't tried.
Are you saying that the Pacific Northwest key is online?
The Pacific Northwest key, that one is online. The Polypore one, yes.
Yeah, some of them are online, some of them aren't.
Yeah.
So half and half.
It's about the Polypore one's online. There's some others too. Polypore one's the example.
And the only problem with the Pacific Key Council is that it focuses on the Pacific Northwest. And so as soon as you're outside of the Pacific Northwest, they're not that great anymore. So once you get into Alberta, it's kind of limited a little bit.
But you know, any of these keys, that's where you've got to start, right?
Yeah.
I mean, you've got to start somewhere, and if you can edit it and add on to it, and if it's a group thing and not like an individual's territory, then it can be built on and improved. It can be. I mean, if you think of the way Wikipedia has gone, it's just a great example of collective editing, creating a very polished and useful tool. And so I think we have that potential in these kinds of keys. So going back to the characteristics that we want here, the other one I think we could add, and I already sort of added it, is it should be electronic. Not a paper thing, but primarily an electronic. So I keep talking about specimens and DNA. Let's ask the question why those are so important, and I'll give you a few examples. If we have what a specimen provides is this historic evidence that can be checked. So that name from 1897 by Earl, we can go back and look at that specimen and say, okay, what was that really? Was this really the Cinceriomyces lindbaddii, or was it something else that? And so there's something physical to go back and look at, and that's so important because when names change and concepts that are hooked to names change, like the way your lecture on Lexinum being a great example, like the way you're using those names might or might not be the same as the way somebody else is using those names. So if you only have the name, you'd think you have the same thing, or you'd think you'd have different things. And you don't really know until you go back and look at those specimens and connect it. What is DNA? Oh, I should go back. I don't think I preached enough on this yet.
And actually, I'll just add that to prove your point, Tom. For years we have foray records, and in Alberta we had tons and tons of Nectria cinnabarina everywhere. And we don't have specimens, but we've got lists. Nectria cinnabarina everywhere. And then all of a sudden in 2007, it all dried up. There's none left. All of a sudden now there's Peniophora rufa around. Because somebody by the name of Dr. Jim Gins came along and said, oh no, the thing you're calling Nectria is actually Peniophora.
Yeah.
And so we've got all this historical data that says, here's all this Nectria. Well, it's not Nectria at all. It's something else, and we were just wrong.
The lists are a great first start.
Yeah.
But to make it credible, it has to be backed up with specimens.
Yeah.
And so when specimens and data are linked, the species concepts become clearer for exactly this reason. And specimens also contain other data, so you can go back to them and get DNA sequences if you didn't get them initially, You can get things like isotopic signatures that can tell you sort of what those are doing or something about the climate at the time. You can get secondary chemicals from it, all kinds of data that you wouldn't think are in those specimens. People come up with clever ways to get it out later. And if it's there, it's a historical record of place, time, and species. So what does DNA tell us? I think the best thing it does is it allows us to compare objectively between regions. So again, it's this thing of are we talking about the same deal? I'm going to give you some examples on how badly we've done with using European names. We all know that we've got a problem here, but the depth of the problem is way worse than I thought it was. It's like a lot of our common species are not what we think they are. And it's DNA that's been telling us that when we compare them, they're different. So it allows us to connect current collections back to types as well. So you can go back and get sequence from type, and then you know, okay, exactly what this name is. And to me, the best thing is it allows us to connect to environmental sequences. The way people like me look at fungal ecology is all through sequence now. That if we want to know who colonizes a particular tree root, we don't look at it morphologically at all. We just pull up the tree roots, grind them up, pull out DNA, and sequence it. We can say, okay, Douglas fir has these however many, and we know place and time where that happened, and it's very comparable across other studies. But if we don't have names to connect it with, they're just unknown sequences. So here's an example of some sequencing we've done. I'm going to slide in now. We've been doing some surveys similar to what you guys do in two of our national parks near San Francisco. So Point Reyes is like 50 miles away. Perfect proving ground for this kind of thing. And we did forays like this over a 3-year period and went from a species list of 135 to over 500 in that time period with everything with collections associated with it. And then we sequenced a whole bunch of those. So this is, and we did the same thing with Yosemite, but haven't gone as far. So this is an example of something that we just threw in as Antilopa Syrian group. And those are the collections, and they look pretty similar to each other, right? But of course, we didn't spend the painstaking time to look through all those and measure spores and all that kind of stuff. But we took pictures, we dried them, and then we sequenced them. And when we do that, what we find out is that, whoops, did I do that? Oh yeah, we did that. Is that we've got 4 different things there, and most of them don't have any equivalent in Europe. That they only match each other. There's no other sequence data that they match, although they're related to other sequence data. So here are some European sequences, but these 2 are strictly from Point Reyes. So we have some endemics, or the whole group hasn't been sequenced enough yet. And it's not just those difficult things. You can look at stuff like Australia. Everybody knows Australia hygrometricus, right? One of the easiest things to identify. Maybe not, because there's lots of species in the group, but according to DNA, and there aren't lots of names. There's like 2 names. And it turns out that a Point Reyes material is not one of the ones that has a name associated with it.
Have they done a lot of the sequencing in Europe already?
There's a lot of sequence. Most of the sequence comes from Europe and North America, although there's a fair amount from Japan now and more coming out of China. But in all areas, it's not comprehensive yet. There's a lot of species for which we don't have representatives. So the Point Reyes sample is in its own little group. Everybody knows the example of Pluteus, but I've got to beat on this. Those are the records from Nanophores for it. So it's actually one of the most commonly reported fungi is Nanophores. It's always abundant. We got it here. You always get it. It was actually the very first fungus that I ever identified on my own from a key. I used 1,000 American fungi and keyed it out and ate it. I was very proud of myself. and I probably had it wrong, because it turns out that it very rarely occurs in North America. That when we look at the sequences, there's a whole bunch of different sequence groups there, and Pluvius cervinus, the one here, we didn't pick up in Point Reyes until recently. We now have found it. We actually do get real cervinus, but it's rare. And instead we get these 3 other groups that are more common, and the names associated with those are not clear yet. So it's a mess. And I could go through other examples, and I'll just duck here so I don't have to keep going away. But here's the Ebernius, the little snotty white Hygrotheris. And Point Reyes, not a match to the Swedish one where the type is. How about Hypothegus? You got that here today. Well, we thought we had in Point Reyes, doesn't match the European one. So different. Recent one was the Alpha Saddles, Helvella lacrinosa, very distinctive species. Everybody learns this right away. No one ever looks at it closely after that. Turned out we had 3 major species groups become the Mexican one. None of them were the European. And so these 2 now have names. The conifer one just got described as Vespertina, and the oak one is now Dryophila. But prior to this, they had no name. So you might think I'm picking just a few examples, but if you take the top 10 most common species from the Point Reyes survey and start going through them, okay, the Melia group was okay because we didn't call it a species, we called it a group, and so it was there. But what we do know is that what mates to Melia in there is by sequence, not Melia. The Western Melia is not Melia, and so we don't really have a name for that. Cervinus, no. Galvella, no. Hypholoma, we don't know yet. We haven't sequenced that. Lucaria, Amethystioxantelis, described from there, so yes, that was right. Inospe sororia was okay. Sarcocypha, coccinea, we haven't checked it yet. The Inospe geophyllum, one of the few Inospes you can learn to identify very quickly. Well, it turns out you can't because it's not right. Ameolins, we had that one wrong. Pungens, yeah, we got it. Well, it was described from there. So it turns out that the things that were described from that area, no problem. But when we were using European names in particular, they were all wrong on the common stuff.
So are you saying, like the Helvella, for example, that they look the same and everything, but once you do the DNA, they're different?
Yes.
Like, how are you ever going to identify which one then unless you do DNA? Like, how are you going to know?
Well, I think on some of the awful ones where there really is no difference and no biology associated with it, what we'll do is call it the lacrinosa group, and as you start to sort out the ones in your area, you'll know, okay, well, it's one of these 2. In our area now, we know that when we pick it up under oak, it's Dryophila, and when we pick it up under conifers, it's Vespertina. And Vespertina, if we go back, actually looks a little different. It often has that little blackish stipe versus the white one.
How do we know that the Europeans haven't gotten it all wrong?
Because it was described in Europe, and so it's linked to a type specimen from Europe. And so when we look at European material, we can say, okay, this is presumably the type sequence, and it doesn't match ours.
So after this, somebody had to rename the species that we found.
So, and a really good example of that is poison pine, Hebeloma crustuliniforme. So we know we have lots of it here, and here in Alberta, it's actually a good edible. And the same mushroom in Europe poisons people on a regular basis. So basically what we really know is that Hebeloma crustuliniforme is not Hebeloma crustuliniforme, but we have no better name for it.
I could have added this on because we sequenced that didn't quite raise. We call it crystallineforme. And it actually, our material did match a European name there, but it wasn't crystallineforme. I forgot, I can't retrieve that from my memory at the moment. But we do, it isn't universal that we don't have any of the European species. We do have some European species, which makes it more confusing. Like, Cervinus actually does exist in North America, but a lot of them are misapplied names.
So why are we trying to tell the Finnish not to eat Gyromicron? I mean, that's
Fun to pick on Finns.
because
I didn't know we were trying to tell the Finns anything.
Well, last night we talked about
Except for Nokia's no good anymore.
that being a poisonous one, that it's been banned in all these countries and they persist to, so it could be a different species.
Could be, yeah. It could easily be.
But does this not perhaps lead you to question the concept of species and the definition of species and how that might apply to fungi? I mean, it works reasonably well with plants and animals. Maybe the whole species concept doesn't.
No, actually it doesn't. What it just tells me is that we've done a really bad job of it so far, because we kind of focus on the obvious characters, and I think it's an honest mistake, but it's also a correctable one. And in groups where the species concept has been looked at ad nauseum, fungi have good species. They have species that are every bit as good as plants and animals, and that really fit a very traditional species concept normally. Sometimes you hear, okay, fungal species are all screwed up. It's not true. They're about as screwed up as plants and animals are, but no more.
I think we have to keep in mind just how many fungi there are.
There's a lot. Yeah.
6 times what there are.
Yeah. But probably not macromycetes.
No.
Okay, you always hear these estimates of fungi. When those estimates come out, they're talking about all fungi. If you limit it to macromycetes, which is what we're talking about here, it's still an intimidating number, but it's not untractable.
What is that number?
I'm coming to it. Although I don't have a good estimate, but. Okay, the last point I want to make about sequence is it's not always, doesn't always end up splitting. This is recent work that Brendan Nathani at Tennessee did, looking at types of Pholiota. And when he did that, what he found was that a whole set of types right here were all identical, saying that the same thing was described with different names multiple times. And there's actually a bunch of examples like this. I was talking over dinner about Rhizopogon is like this, that there's a whole bunch of species that were re-described, same name, by actually the same author. He didn't, So there's this kind of mess to clean up too, and it's going to take sequences to do that. And then I just wanted to show you kind of a flow diagram for how sequences get used in ecology. This is actually dated now, and I'll update it slightly. But in mycorrhizal ecology, what we were doing is just pulling out root tips that looked something like that, grinding those up and sequencing them, and then matching the sequence to something, and then we could say, okay, that's Pseudomonas pungens. And that in the old days you could do this without it, but mostly you came up with black types and E strains and things that we didn't really know what they were. And so molecules just blew the lid off this and made it useful. But the only thing that really allowed us to connect it up with names were specimens that had a good name on them and were sequenced. Yet otherwise, there's no database to compare, and you just go from an unknown mycorrhizal type to an unknown mycorrhizal type with an unknown sequence. So not a huge advance. These days, the way it actually works is you just extract from soil. You sequence everything at once, get like 1 million sequence reads off an area, and then you apply some bioinformatic techniques to sort out all of those and into species-sized groups and then match it to the database and figure out what you have. And this works great for getting papers, but because the database stinks, most of those species names, are either you can't figure out what it is or they're misapplied. So we really need a good database, and it's dependent on these specimens. The other thing I want to point out about sequences is it can expand what you know about species. So this is a species that looks a lot like Sulos brevipes. It's a dead ringer for it. The only way you can tell this apart, other than sequence, is when it first comes up. It's not that chocolate colored. It's a lighter color when it first comes up. And then when it matures, it looks just like brevipes, except it'll get some little glandular dots on the stipe that could easily be missed. This was originally described down here in Santa Cruz Island. And the way that this happened, I was in Santa Cruz Island, and it was there were so many of these that it was obvious it was different. You know, it's like when you get one collection of something and you look at it and you go, oh, okay, well, that's just a weird little brevipes. You know, it came up, you know, it had a hard life and it was dried out and whatever, and so it looks different. But when you see, 20 collections of it over a couple of days, you go, this thing is not brevipes. I don't know what it is, but it's not brevipes. So, we went and sequenced it and we described it. But at the time, it was only known from Santa Cruz Island, except by sequence, that we could match that sequence to a bunch of other studies. And so all of the yellow distribution there were due to sequence studies on roots. So we knew this thing was elsewhere, but we hadn't seen it. We'd only seen it from Santa Cruz Island. So now we've expanded this slightly in that we've picked up a bunch of other specimens of it. And I'd like to say it's now that we know what it looks like, but no, we picked it up thinking we had brevipes. And then when we sequenced it, we went, okay, it's classes.
Am I getting a connection between the roots of a tree and mushroom?
Yes.
Is that what you're talking about?
Yes.
It's the same
Yeah,
DNA.
so we're sequencing the mycorrhizal root tips off the pine.
So that it has a DNA is identical.
Yeah. Yeah, I could go into how we do this more, but it's it's the way we do it now. So you can see it still goes up, and I swear some of the stuff we were picking up here looked like it could have been quiescence to me. So this could be the tip of the iceberg. It might have a much broader distribution, and it's just been parading as brevipes all these years because it looks just like it. It's really hard to tell apart, and it's so hard to tell apart that I always screw it up, even though I described it. All right. So what do we need to do to produce this thing? If we want to make a North American Microflora, what do we need to do? We need to assemble all the existing data and records. We certainly need new sequence acquisition and analysis. We have a lot of new species to describe. We've got to sample a lot more. We've got to create these monographs. We're going to need more people. And we're going to have to set some realistic short-term goals and get going. We've got to find money. So let's go through these here. And the first steps are starting to get done in terms of assembling the existing records. This is a large grant that got funded through the New York Botanical Gardens to take all of the fungal collections, unfortunately, in the United States, and put them together into this microportal. The mastermind behind this was Barbara Tears, the daughter of Harry Tears, the mycologist from San Francisco State, who's passed away a decade ago now. And here's her picture from that Microflora workshop that we had. So this is what it looks like. That's the herbarium that we're going to connect the records on. So we're going to have a lot of data up online, and this is the first ones are just starting to come up. If you watch Microportal now, you can start to see this data assemble, and it's cool. It's really amazing what it's going to look like. It's very American. It stops right at the border. It's awful. I'm going to come back to that point.
Where's Alaska?
It's up there to the north.
It's up there. It doesn't have much of a fungal herbarium, surprisingly.
I'd like to ask you a question.
Yes.
If a lot of the collections that are in Hungarians are actually inaccurate in terms of names, why bother? Like, why don't you just start with DNA straight? Like, that's a lot of work to do, to collect all that information from all those different institutions and put it all together. That's an enormous amount of work. Rather than just start sequencing.
Yeah.
You know what I mean?
Yes. I think there's still value in this, even though a lot of the names are bad. Because if you're doing a monograph of, say, Suolus or something, and then you can pull up those records and you can look at it and go, what's Revipes doing down in Florida? Then you can pull up that, you can get that specimen and look at it and find out, okay, is this really real? And if you didn't have that assembled, you wouldn't know that there was this conflicting data. And maybe it's real. Maybe it's real.
But you could also just skip that step. Just take the mushroom from Florida, sequence it, then you know what you got.
You're starting from scratch.
Then you're starting from scratch.
But are they doing DNA from these collections?
No. No. So these will be just the data from those collections. And 1 in 10 images get scanned. So you get an image of a dried up little hunk of crap that's been in the herbarium for a decade or more. But all of the types, for example, will be scanned. So you'll be able to see, okay, is there anything in that type worth pulling out and sequencing, for example?
So, Tom, just for your info, in Alberta we've done that. The Alberta Mycological Society has gone through all the records,
right,
and we've done this already. So we've taken a huge step towards.
We rock.
We absolutely rock.
I'm going to come back to the Canadian contribution here, mostly because Scott Redhead was at this meeting and he was like, "Where's Canada here?" He's also been assembling records, and there's a lot of independent assemblage. We really need to get in one searchable database, and I think everybody's on the same page with that, except the funding agencies. That funding agencies have this political overlay where I don't want my money from Texas going up to the Canadians, So you get that kind of thing going on, and it isn't scientifically driven. It's politically driven. But every scientist at this meeting was on the same page on that the fungi don't stop at the border, either north or south. If we want a North American Microflora, it has to include Canada and Mexico.
I might add that one thing that really bedevils combining different databases are the simplest damn things like the format of the date.
Yeah.
It would just be a nightmare.
or the format of.
But fortunately, it won't be our nightmare.
I noticed the biggest state in the Union doesn't have a site.
The what?
The biggest state in the United States doesn't have a site.
Yeah.
So I want to point out, these are the herbarium locations.
They
It's
execute.
not the specimen.
Right. Yeah. So, like the first one that was done with New York Botanical Gardens has specimens from all over the world, right? So as you're getting these, you're filling them in. So it's going to be digitalized. Lots of numbers involved. Estimated 70,000 specimen images, and that's again 1/10 of the total specimens. And the data is going to get assembled through Mycoportal, and you can already go on Mycoportal and get information out, and it's actually fun to do. And you can have personal collections in Mycoportal where you put in your data and get it in the right format, and it's really easy to put into a herbarium from there, including images and everything. So it's a useful site to look at. If you've never looked at this site, you should. It's going to only get better over time.
How is the funding done now with most of the sequencing? I mean, is it universities, or where is the funding coming from?
For sequencing at the moment, it's individual projects, and there's no unified way to do this for this kind of project. The place that it should get done was the Barcode of Life Consortium, that is a Canadian-driven project. But that also has some weird politics going on, and basically I bugged this guy up at Guelph a lot, to the point where he doesn't answer my phone, or his phone, or emails anymore. But his basic answer is that he's not interested in fungi.
Oh.
Yeah.
What does that mean?
Yeah. You got a pound. I don't want my Canadian dollars going into birds. So this is a Mycorrhizal map, and it shows the collections that are for brevipedes that are currently in the database, and that's only mostly New York Botanical Gardens at the moment, and Michigan, I think.
Something wrong with the scale of that map.
Pardon?
Something wrong with the scale of that map. Canada is almost the size of Mexico.
Well, it's a Mercator projection, but
Yankee projection.
but what you can see is that even with just some data in there, you can start to get a grip on the distribution. But you can also see that there's no points in Alberta. So the herbarium that's so far been digitalized had no Alberta collections of it. And also, if you overlay Mushroom Observer on here, people that think they've seen it, it goes down into Mexico and down further down the coast into Florida and so on. So, you know, someday we'll be able to do this. And on each of these, again, you can click on that and pull up the record, you know, and see, okay, who said it was there? When did they collect it? So it's really a cool tool. Okay, so
And actually, we'll just say that that's very much like our database is. So we've got points like that. So if you, I don't know if we've input Sewell's brevipiece, but if we have input a bunch of stuff. So again, if you hit the point, you can see who collected it when and whatnot on a map.
that is the beauty of the internet, right? Is linking all these different kinds of data. And the other links are also to sequence. You can pull up, you can go to from this straight to the GenBank sequence that's connected with that. Or vice versa. If you're in GenBank, you can link back out to it. So, you know, it'll be convenient. So, how big's the problem? Let's go to that. There was a big paper in biodiversity a few years ago now that Greg Mueller and a bunch of collaborators put together. Based on that, they said that there was 10,000 macromycete names, basically, that are in North America. And 65% of those were unique to the continent. So 10,000. But this is Greg, and what he says is, however, the data sets for each region are woefully incomplete, and most taxonomic groups have not been recently monographed, so numerous cryptic species will likely be uncovered. The kind of thing that I was just showing you.
It was a quick and dirty list.
It was a quick and dirty list.
I did part of it.
Yeah.
It was just grabbing all the names and put out the books.
But I think what you can say is it's a minimum estimate, right? There's certainly no less than that. You know, and if it was tenfold higher, you'd be looking at 100,000. Pretty intimidating. And it might, but I would bet it's somewhere between that and 10. It's a significant number.
Would cryptic species be just what you described earlier, where you've got?
Cryptic means hidden. So they're species that we see every day, and we think it's something else because we don't really see the differences.
Like all the different honey mushrooms. They all used to be honey mushrooms.
Yeah. Yeah.
So different.
Yeah. And in some ways, they're still cryptic because we can collect them here, and we can't really sort them out. Yeah. How much sequencing we need to do? So if we do have 10,000 species, if you just got 10 accessions for each one, you'd be looking at 100,000 sequences. And I think 10 would be sort of a minimum that you want to maybe capture whether that thing is one entity or many. Obviously, we want the sequence to be widely available, and so I think a centralized facility is what we really need. I've had a lot of discussion with people here about that, about how can we get stuff sequenced. I think the solution to that has to be a central facility that will do it for us for some price.
Beijing.
Well, it could be Beijing. Yeah, it could be, or Korea, hopefully south.
We could employ every North Korean.
Yeah, each one gets to work on one base. Yeah.
Smashing them with hammers.
But no, seriously, I'm sure the price would be much, much lower, and the speed of producing it would be much quicker if there was a central facility. And the ironic thing is, there is such a facility. It's in Canada. It's in Guelph. It's the Consortium for the Barcoding of Life. But they're sort of obsessed by large animals, it seems like, and insects a bit.
And you should send me their email address and phone number and we'll all phone.
Yeah, I don't know the most effective way to do it. I mean, I think the most effective way to do it would be deal with their funding agencies, not them. One of their big funding agencies was Sloan Foundation, but I think that the plug has been pulled on that one, and that's part of the problem. And I think that if we came up with money, it would be a different story. If you say, well, we've got these 100,000 things we want to sequence, and we've got money for you, they'd go, step right in. So trying to get them to do it for us gratis isn't going to happen. But I think if we had money, it might be the way to go. But we could work around them too, because it'd probably be cheaper to go to Beijing or somewhere like that. But they, in top of doing the sequencing, they also have great databases and stuff for keeping records on the barcoding approach. So they really would be a great way to do it. And I just, I'm really not enough of a diplomat. I'm not a diplomat when I talk to people like this, and they don't see it my way. So somebody with more ability to schmooze needs to talk to him.
What's his next project?
All right. So to do all this stuff, I think the next thing is obvious is we need to recruit more people. Because one of the big problems is there just aren't that many people studying these, really. I mean, taxonomy, a lot of the collecting and identifying of fungi has been taken over by people like you. And it's because people like me can't get a job doing it. Like, I don't do this. If I did, I wouldn't have a job at Berkeley. And that's the truth of it at the moment, is that it's very hard to be a professional taxonomist. So, we're going to have to make do with people that, have day jobs, but a burning interest. So, Tim Baroni kind of summarizes it. He says, the issue I foresee is gathering a critical mass of workers to produce such a product. North America is a big piece of real estate with a significant number of taxa yet to be described in most all groups of macrofungus. Bingo. Without the numbers, it's just not going to happen. And Karen Nakasone, I should have mentioned that Tim is one of the big Entoloma people in North America. But he works at a small school where he teaches, a big course load, and does a lot in spite of it. Karen Nakasone works at the Forest Service. She works on recipitate corticioid fungi and so on. And she said, this Microflora North American Microflora is something I'm interested in, but never imagined it could be done. Too many species and not enough taxonomists. And I think that, you know, I can't but agree with that. So what progress has been made? Well, I mentioned the digitalization, but I should also mention NAMA. That NAMA has the voucher program, and we have, I'm actually pinching the slides here from Pat's talk at the workshop. And out of date now because we haven't added a few of these, but you can see there's, it's on automatic now. Let's go back. There's a lot of collecting by NAMA across the continent, and your question about why don't we just do it with new material, I think we could with stuff like this, but a lot of the NAMA collections are very similar to what you've got here, where it's a very quick look at the specimen, you slap a close name on, it goes in a plastic bag, and they pile up. And so turning this into a useful tool, I think is going to take some money, basically, so that somebody has time to look through this stuff and start to do something with it, and get the sequences out, get the images up, and get good names on it. But the raw material is being collected. But if you look at how the names have progressed over time, they keep adding to it. That you know, what you want on a collecting curve is a plateau, right? No evidence of a plateau here. We've got a long way to go, is what that says. This is on automatic, but that one was okay. We'll go back through it once more, so we have a little time. So Mushroom Observer, this was from 2012. At that point, they had 86,000 observations. So people are, you know, logging fungi in, and this shows where those observations come from. So you can see they're enriched in certain areas, and there's some areas where there's almost nobody out there. But it's a lot better than the kind of sampling we're getting from individual mycologists at a few institutions, right? That this is actually the eyes and ears of the continent that are starting to see fungi and record them. And getting people to go beyond just making a visual record and getting them to collect a specimen, I think is just all that needs to get done to start making this a much more useful tool. So I think we can connect these existing web platforms together. We can take herbarium databases and connect them through the Mycoportal, and this could be a primary repository for specimens and analytical tools for the geographic information retrieval. You can use Mushroom Observer or Mycoportal as a primary entry point for images and data for new collections. Discover Life for the primary key production, so those synoptic keys. GenBank, or I didn't talk about Unite, but a different, more curated database for deposition of sequences. And since I made this, there's been some work with Unite to actually annotate the sequence database better so that we correct the names. And I think the last thing we need here is we need funding. Going back to Tim, he actually sent me quite a few emails. He hit the nail on the head here where he said, the money to do this work would serve as an important factor to bring morphological taxonomists into a group effort. We basically have been pushed off of North America to tropical regions in the past 2 decades to obtain funding for the work. This is again, a political, kind of scientific political thing, but it's way, way easier to go off to Borneo or South America or Australia to collect and identify fungi than it is to do it in North America. Because the perception of non-mycologists is, well, North America is boring, we know it, it's all done. Yeah. So, what would funding do for us? The biggest thing it would do, I think, is pay people that do work. So it would pay postdocs and students and professionals to actually write monographs and assemble this data and sequence and that kind of stuff. It would pay for traveling for collecting. It would pay for curation of specimens, pay for web-related construction and upkeep, and pay for sequencing. And then coming back to Tim's issue, it would allow young taxonomists to work in North America and still achieve tenure. Because you don't achieve tenure if you don't get grants, and you don't get grants if you're working in North America taxonomy. Let's come back to Canada. Funding has to be available, across the whole continent, or we don't really have a continental microflora. We have a U.S. Mycoflora, and it doesn't, the fungi don't actually stop at the border, even if they have to go through security. And they do. Scott Redhead said, put it well, says Canada covers a rather large land mass. Couldn't you hear Scott saying this? For North America, and yet I don't see much from Canada in the program. He's talking about the Microflora program last year, or among the attendees. The reason he didn't see much was that we had grant money to bring people into this program, and we could not spend it on foreign scientists. Yeah, so the few that we got in there, we did sort of the shell game of paying some extra things in the MSA meeting, and then they paid for people like Scott and a few others to come in. But it's an international thing. It's not a North or a U.S. thing. So hard sell there. So rough estimate of funding. I'll cut all this and just go to the numbers. I think we need about 18 million to do this. So what we're looking for is a check tonight. What we're looking for is a sugar daddy here. What we need is some connection to some of the big foundations, because 18 million for some of these foundations is, like the kind of spare change they sweep up at the end of the
Ministry
day.
of Defense.
Oh. This is like, what, 2 cruise missiles? And we could fund the North American Mycoflora for 10 years. Yeah, we could start there. But so it's a huge amount of money, I think, that we really need. And I'm not sure, how we'll get there. So we might ask, without additional funding, what can we do? I think we can start with the pieces for which we can find money and start doing those. And that's kind of ongoing, this thing of digitalizing. Okay, that piece got filled in. So we can start doing some things. And we can coordinate these pieces so they fit together. And then I could ask, what can you do? You can continue honing your taxonomic skills, right? And that's kind of what this is about. You come here and you learn from each other how to identify fungi and how to get better at it. You become obsessed, hopefully, and you get better at it. And if you are better already, you can help train others, which is what a lot of the rest of you have been doing. So you can do what you're already doing, essentially, only more of it. You can do things like write a discoverlife.org key. You could do a key to the Russulas of Alberta. Probably not tomorrow, but you could probably do Suillus of Alberta tomorrow. You could probably sit down and do that in a relatively short time. A few of the groups that you do know, and then you start to add it in incrementally.
And
I can save specimens.
I want to interrupt because that's something that I would really like to do. I would like to have, if we have generally some keys for Alan and I, Alan loving me and saying, you've written some keys for Russula and some Lacarius and Suillus and whatnot. But what I'd really like to do is to maybe during the winter time is on a Saturday and on a Sunday get together and write some keys. And we can do a little key writing workshop. And what you need is you need people and a little bit of time and a little bit of literature, and we go through, and it's such a great way to learn about the group that because you're looking at differences and you're writing keys, and those are things that I've been kind of wanting to encourage the society to do, and we've just never managed to actually do that. So
with
stuff is in the process.
With the synoptic keys, what you start with are basically the images. You sit down and you go, okay, what are all the characters that we're going to need for each of these? And you start assembling those images. And the list of names. And once you have that list of names across the characters with the images, you can assemble it. And again, PIC is very helpful on this, and you know, it can be done. I would start with something doable and small, and I think it would start rolling if a few people did this. Excuse me. And the next thing, save specimens. And by the way, save specimens. And save more specimens, and take good data on them. So it's not just a dried thing in a bag, but it's a dried thing in a bag with location, with an image, maybe with microscopic features on it, and hopefully a good name. Because that's the basis to it all, is that we need specimens.
So those cards that everybody's been filling out and has information on it, even though it gets entered into the database, should that card go with the specimen?
Probably, yes. Yes.
We do that for Nono.
Yeah.
Because we have data entry errors. And I go back and check. And
Right.
there might have been some written on the back of the card. But we do keep all cards. And that's true for really old specimens. Every scrap of paper that was...
Yeah, when somebody changes a name, it goes on a little scrap of paper, right? But the original one is still there. Yeah.
Tom, how much was a GPS cost?
I don't know, but I just lost mine in the field today, so I've got to go find it out.
It fell out of your pocket or what?
I don't know what I did with it. I was carrying it, and then it just vanished.
Because
I think it was delirious with...
If every group of 4 people went out, there was one GPS amongst them.
Yeah. You know, the GPS is not that critical, because usually one GPS for the area is really what you need. You're not trying to nail it with each specimen. And you can get that post fact off Google Maps. You can just call up the area and get a good GPS for that. And it's as good for this purpose, I think, as a GPS. So I don't think that's a critical piece of equipment. But the coordinates are critical. You can help survey your area, which is what you're doing. So I would encourage people to think big.
Oh boy. Nice.
You know, it's a big continent, and there's a lot of fungi out there, and they're not all this obvious. You know, so...
There's a lot of little people out there.
Keep your eye up for fairies.
That's what actually is stat.
That's my way up, actually, under there, from a few years back. Do you know the species?
I think so.
This is Boletus photoshopus.
Yeah.
And it's in its natural habitat, the digital photo. So what I'm saying is, you know, let's start putting the pieces of the puzzle together. And even if we start small, if we you know, have a plan for how these pieces are going to go together, it will sort of self-assemble, and it won't be perfect, and it won't be seamless, and it won't be everything we want right away. But if it's a web-based thing, I think it can be refined over time in kind of a Wikipedia-like model until it's a really, really useful tool. And as Wikipedia is a very open project where all people can contribute, I think that's the only way this is going to happen. If it's like half a dozen or a dozen people that sit down and do this, it's not going to work. It's going to take lots and lots of people that are interested. And so I'm glad that people like you are. So that's my preaching. Thank you.